sequence for chapter 1 and 2. Okay. 2.1, are there any existing questions that you still don't understand for the simultaneous equations? Okay, I give you homework and your homework practice. Okay? Yeah. So, exercise 2.1. Okay, homework. I want you to do question 3C, 5B, and 10. This is in the textbook page 1. Okay, when can this homework be due? Monday? Monday? Any violent objections? Yeah? So till Monday. Yesterday after I returned, I left the class, I did go back, reflect a little bit. I go too fast. Maybe I didn't account for the different profiles that you all have. But I also thought that simultaneous equation was something familiar, but I think I took that for granted. So I might have gone a little bit too fast. But 1.1. It's something that is also familiar to us regarding completing the square. But I'll adjust my pace a little bit. But I also want you to manage your expectations. Our pacing will slowly increase. Otherwise, we may end up falling back behind as well. There is a lot of content to cover. And to manage our expectations, for A-Maths, there is a lot of algebraic concepts required. So I would expect that when you expand things like maybe 1 plus b squared, you are able to very quickly tell me that 1 plus 2b plus b squared. If you still have the habit of putting it into 1 plus b, 1 plus b, and then do your rainbow method, then I think you need to really adjust to use your formula. Why do I say this? Because I saw that in your E-Maths homework. There is still some people who do this stuff. Although nothing wrong, nothing wrong with it, but you know that by doing this, it does set you back a little because it takes some time. So I need us to really upgrade. In fact, I think next year we will learn how to do 1 plus b power 10, that's using a binomial. And that's another formula on its own. So if it's like that, it's not possible that you want to do this anymore, right? It's not possible. So we need to be familiar with formula and be able to apply them quickly now. But this one is for next year. Now, chapter 1.1, we're looking at quadratic functions for this entire chapter. We are looking at maximum and minimum values, which actually we are familiar with already based on what we did in E-Maths. But there are certain notations that maybe we are not familiar with. For example, fx. So we are familiar with how sometimes we write equations like that, quadratic, y equals to 2x squared plus maybe 3x plus 7. So what exactly is fx? Fx tells us that it is a function, in terms of x, whereby x is a variable, so an alternate is somewhat like an alternative to using y. So we can instead write it as fx equals to 2x squared plus 3x plus 7. substitute, let's say when x is equals to 2, when I use version number 1, I will usually have to go y equals to 2 squared plus 3, 2 plus 7, and then I calculate, right? Okay? So in fact, I still need this kind of statement. But when I want to let x be equals to 2, using my function statement, I can just simply write f2 equals to 2 squared plus 3, 2 plus 7. Okay? Now, just to be clear, writing fx, okay, itself, it is not f times x, okay, the brackets is not meant to represent a multiplication at all. Okay, it is to show that we're looking at a function where the insides are in terms of x. Okay, that is what the brackets serve to mean. Okay, it is not telling us that it is f times x. Okay. Other than using the letter f, okay, to represent functions, sometimes we do use things like gx, hx, okay, we do use other letters as well to differentiate the naming, okay, because you cannot have everything named as fx, okay, especially if the function is different itself. Okay, so that is a matter of notation, right, that we use something similar to how y works, just that the way we use it is slightly different. Okay, you see more of that as we do more questions, especially when we arrive at chapter 3 of AMAS. Okay, so we look at an example first. Of how this notation is being used. Okay, we define the function as negative 2x squared plus 4. Okay, so fx is being defined this way. This is what fx means. Okay. In part I, we want to find what is function when x is equals to negative 1. So we want to determine the value, okay, when x is negative 1. So we will let negative 2 or your x to be negative 1 and then plus 4. So in this case, it computes out to be a value of 2. So your f negative 1 is 2. So that is the convenience. I don't have to say when x equals to negative 1, then we find the value. We just replace the x with negative 1 and everybody will know what it means. Okay? Or at least everybody who learns maths now. Okay? Questions? Now, part 2. We want to find all possible real values of fx. I think I kind of addressed it before. Okay, real values are just all the numbers that we encounter, okay, in our math syllabus. The opposite of real values will be complex values, right, which we will not be covering in our O-level syllabus. Okay, it's not fake values at all. Yeah. What do you mean exactly perfect? Answer. The answer bank. Actually, AMAS don't have this answer bank. Yeah. AMAS format doesn't have this answer bank. Yeah. So everything here is not. Yeah. Okay. That's the exam format. Okay, we don't have this answer bank. Okay, but good question. But I didn't think that I needed to say that. So, part 2. To find all possible real values of fx, that means we want to find all the, okay, using the same words again, the range of values, okay, that fx can be. So we know that 2 is one of them. Okay, but it's not possible, it doesn't make sense that I will go and substitute all the possible values of x1. Okay, I go and put in 0, then I see what's the number. Put in 2, see what's the number. Okay, 1000, I put in, I see what's the number. It doesn't make sense. Okay, because there are so many numbers. Alright, I'm not going to substitute it into this function to know what are all the possible real values. Okay, so we need to look at the function itself. So the function that we're looking at is negative 2x squared plus 4. Okay, when we were doing Emaths, we have agreed that x squared is always more than or equals to 0 regardless of the value of x. Okay, when I say regardless of the value of x, I also mean that it is for all values of x. You will find such statements very commonly used, especially in our Emaths. Okay, so this actually means regardless of any value. Okay, so be it going to be 1000, going to be negative 1000, negative million, or a fraction. Okay, so we have already established that understanding that x squared will always be more than or equals to 0. We established the understanding, yeah? Okay, so because we know this, and x is actually the variable. Okay, because x is the one that influences what fx is going to be. Okay, it is not going to be negative 2 or 4 because those are constants found inside the entire equation, the entire function itself. X is the one that keeps on changing, that's why it's called variable. So with x squared always being more than or equals to 0, okay, what can we then say about negative 2x squared? Okay, it is about multiplying negative number on both sides of the inequality, and we know that it will be less than or equals to 0. Okay, agree? Right, so from here we arrive at this step. Okay, don't forget we are trying to find all the possibilities. It doesn't mean that I have to list all the possibilities because we acknowledge that it's not possible. Okay, because there are so many values of x. I can never list out all the possibilities. Okay, it's not like it's one set of like 5 values. It's an indefinite, infinite set itself. Okay, then we plus 4. Okay, and we find that plus 4 on both sides of the inequality, we will get less than or equals to 4. So what does this mean? This expression over here is our fx. It means that fx is less than or equals to 4. So all the possible real values of fx, okay, will be anything 4 otherwise lesser. So it can be 3.9, it can be 3.9999, it can be 3.8. Okay, but can it be 5? Never. Okay, because this inequality tells us that fx will be a value that is lesser than or equals to 4. You understand? Yes, teacher.
Why is it minus 2x smaller than 0?
Why is negative 2x squared less than or equals to 0? Because we agreed that when I have an inequality and I multiply it by a negative number, both sides of the inequality, your inequality sign changes. It flips one. We have agreed that with that when we look at chapter 2 in Emaths.
You multiply by a negative.
Yeah. Remember I said 24 is more than 4. If I multiply by negative 2 on both sides, I'll get negative 48 and negative 8. Which one is bigger? Negative 8 is bigger, right? So we have established that when I multiply by a negative number, inequality sign flips. So that's the reason why inequality sign has flipped over here. Because I multiply by negative 2. Okay, why do I even bother to apply multiply negative 2? Because that is the function that we're looking at. Our function has negative 2 inside. We want to multiply negative 2 to 2 first. Okay? We don't go and add 4 first. Because if you add 4, then you multiply negative 2, then your 4 will get multiplied also. Okay? So that's why we do the one that's closest before dealing with the one that's furthest. Yes. Correct. Because if you imagine, you want to add 4 first, right? Okay. X squared more than equals to 0. You go and add 4 first. You do get this. Then you go and multiply negative 2. It is negative 2 to the whole expression. squared plus, sorry, this one not this side, okay? And then we get this. But this itself is not our function. Okay, so it doesn't make sense to add 4 first, then you multiply by negative 2. Okay, so we always multiply the number closest, then we do the addition, subtraction, whatsoever. Okay, questions? Okay, I let you go and let you think through about it. Okay, then tomorrow, okay, we will talk more about it. Because this is a concept that I was trying to build towards when we did our e-maths.